Hello everyone, welcome to day 16 of our SOC 100 Days Learning Challenge. So, you have made it this far. So, let's dive into a topic that's going to level up your malware detection game, YARA rules. Alright, so what we will cover in this session. So, in today's session, we are going to walk through what are YARA rules, why should you care about YARA, how do you YARA rule work, rule structure, example of a single YARA rule, how to use YARA rule for malware detection, best practices for writing YARA rule, popular YARA rule sources, and bonus section with popular YARA rule for malware detection, and then wrap it up. So think of this as your detective toolkit for spotting malware, and YARA is the magnifying glass you will use to uncover those tiny bits of malicious code that try to hide in your system. All right, so what are YARA rules? So let's start with the basics. YARA, the full form is yet another recursive acronyms, the YARA. So yes, it is recursive, is a tool used for identifying and classifying malware based on pattern. You can think of it as signature based detection tool that looks for a specific byte pattern or characteristic string in file. The cool part, you can write custom rule to describe those pattern. Basically, you are building your own malware fingerprint scanner. So YARA rule is used in malware analysis, threat hunting, incident response, threat intelligence, and detection engineering. Cool, right? All right, so why should you care about YARA? So you might be thinking, why do I need YARA when I have already got antivirus software and endpoint protection? Fair question. Here is why. Custom rules like YARA allows you to write highly specific detection rule based on your characteristic of malware that your existing tool might miss. Also, flexibility. So you can create rules for any type of malware, whether it is a Trojan, ransomware, or backdoor. YARA can be adapted for search for pattern across files, memory dumps, network traffic, and more. Malware hunting, so it's especially useful in the world of malware analysis. Analyst can create rule based on malware behavior, file structure, or even command and control pattern. Cross platform, so YARA is not tied to any particular OS or tools, make it highly adaptable. You can use it on Linux, Windows, or Mac OS. And it is open source, so YARA is free and open source, so you can modify and improve it to suit your need. So plus there is a huge community of security professionals contributing to YARA rules. So this is pretty popular in malware analysis. uh, let's jump on the next one. How do YARA rule work? So a YARA rule is essentially a pattern match. So the rule you write looks for a specific string or byte sequence within file, memory, network, and the other associated with known malware or indicator of compromise, the IOCs. So these pattern can include specific file headers or footers that indicate a known malware type, string, so string like text or binary that are found in the code of the malware. uh, Also the conditions like logic operators, so that help refine the searches. So here you can see a example how YARA works. So here is the YARA rule working with API keys, and here our Amazon guard duty. So it is working with various type of bucket, S3 buckets, and S3 buckets are sending data to a centralized place. And here we have our YARA with our correlation detection rules. And here you can see the bad actor. So we can detect all the bad actors activities with integrating YARA with some other tools, and SOC can strongly respond on the attack. Then rule structure. So here is what YARA rules typically look like. Let's break it down. So YARA contains three main parts: meta, string, and condition. So number one, meta. So this section contains metadata about the rule, who wrote it, when it was last updated, etc. So this is mostly for documentation purpose. And then second one, strings. So this is where you define the actual pattern, the strings or byte sequences. So you're looking, suppose you're looking for any malware, you can write the string here. And the third one, we have condition. So condition is like a logic that you can apply to detect or match the rule. So here you can see uh, a YARA rule to detect the MITRE technique T1055, and this is sub technique, the process injection. And the meta part, so this is the meta part. So meta part contains all the details like process injection details, the MITRE framework, etc. And then string part. So string part, you can see the pattern for searching. So we have pattern A, B, C, D, and E. And what it is checking? So it is checking some commands like create remote thread, anti-create threadx, and q user apc. So these are the strings or commands we are checking in the string section. Then we have condition. So condition says if any one of these matches in the log, fire an alert or notify to the SIEM system. Then here is a simple YARA rule example. So let's look at more practical example. So this rule is looking for known piece of malware. So you can see the meta. Meta says description, author detail, etc. So this is meta. So this rule is going to check for the ransomware string. So here is the string for ransomware. So string one is malicious code, and string hex is this. And then we have a condition here. So if string 1 or hex 1 matches, so this rule is going to trigger. Next, how to use YARA rule for malware detection. So okay, so number one, writing your own rule. So one of the most powerful things about YARA is that it allows you to write custom rule for any kind of malware, unique characteristics you have identified. So start by identifying pattern in the malware samples you are analyzing. So that could include the string, bit pattern or byte pattern, metadata, etc. So once you identified the characteristic, write your rule. The best practice is to be specific to avoid false positive. Then number two, running YARA against the file. So once you have your rule ready, you can run YARA against file on your system or network. So the command is super simple. You can start with YARA, then rule file path to scan. So this will scan all the files in the specified directory path slash to slash scan, and apply the rule defined in your rule file dot YARA. So if any file match the rule, YARA will output a hit and the name of the matching rule. Then number three, uh, integration. So integrate YARA rule with your SIEM or any security tool. So you can automate YARA scan and integrate them with your existing security tool like your SIEM. For example, some SIEM platform like Elasticsearch or Splunk support YARA rule integration, allowing you to automate malware detection in real time. Uh, Also, you can use the endpoint protection. So some platform, endpoint platform, if you're using like OSSEC or Suricata, you can also integrate YARA to enhance detection. Number four, scanning memory or network traffic. So you're not limited to just files. YARA can also be used to scan memory dumps. So if you are suspect malware is running in memory, you can scan memory dump using YARA. Then we have network traffic. So you can even write YARA rules to look for pattern in network traffic, easy known command and control domain, or suspicious payload, etc. So best practice for writing YARA rules. So when writing YARA rules, it is essential to follow a few best practice to maximize effectiveness. Number one, be specific but not too specific. So if your rule is too general, you will get a lot of false positive. If it is not too specific, you may miss new variants of the malware. So it is all about balance. Number two, use multiple strings. So combine string like text and byte patterns in your rule to make them more robust. So a combination of pattern is more likely to trigger for the right malware. Then test your rule. So always test your YARA rule on set of known malware sample and benign files to ensure they work correctly without too many false positives. Then keep rule updated with latest IOCs. So malware evolve quickly, so it is important to keep your rules up to date with the latest malware variants. So by using these patterns, you can avoid the false positive and write the good YARA rules. Then next we have popular YARA rule sources. So want to see some real world YARA rules in action? So here are a few places where you can find community contributed YARA rules. Number one, the official YARA GitHub repo. So the YARA official repository is a great place to start. Then we have OpenDXL rule collection. So this provides an extensive collection of YARA rules for detecting various type of malware. Then also we have MISP, the malware information sharing platform. So this is community driven platform often share YARA rules to help detect IOCs associated with specific malware campaigns. And also you can find YARA rules on security research communities or X or LinkedIn or any other platform where you can find a good community. All right, so here we have bonus section and we are going to cover some popular YARA rules for malware detection. So number one, we have ransomware detecting Ryuk malware. So uh, Ryuk is the one of the most infamous ransomware family, known for its destructive attack on high-profile organizations. So this rule identifies Ryuk by looking for unique string and file pattern used by the malware. So you can see the meta description for that, author, date, etc. Then a string. This is very important part. So the string is going to check the Ryuk ASCII, then RYK ASCII, then here is the hex dumps, and then condition. When any of these string matches, then it is going to fire an alarm. The number two, Emotet dropper. So Emotet is a sophisticated malware strain that often act as a dropper for other malware such as ransomware and information stealer. So this YARA rule identifies the distinctive characteristic of Emotet dropper payload. So here you can see the meta contains all the details, and then a string, so it is going to check the ASCII and the hex for the Emotet, and the condition is same. So Emotet dropper executable has easily identifiable strings like Emotet and Emotet, the small one and capital one. So by searching for these strings, you can detect Emotet payload even if it is not fully executed yet. Then number three, we have Zeus Panda Trojan. So Zeus Panda is part of well-known Zeus family of banking Trojan, often used to steal login credentials from financial institutions. So this YARA rule look for specific string and behavior in Zeus Panda variants. So this is metadata and this is a string. So in a string, it is going to check for the Zeus ASCII and Panda ASCII and the hex, and the condition is uh, any of these string matches. So it is going to trigger an alert. So the Zeus Panda Trojan uses distinctive string like Zeus and Panda in its code. So these strings are typically present in the Zeus Panda's malware payload, making it relatively easy to detect. Then Mimikatz detection. So Mimikatz is well-known post-exploitation tool used to dump Windows credential from memory. So it is often used by attackers once they have gained access to a system to escalate privilege or move laterally. So this rule flag the presence of Mimikatz on the system. This is metadata and the string. So Mimikatz uses a specific string like Mimikatz and sec urlsa, so you can see, and then here are some hex. So so this is going to use for password dumping and credential extraction. So by detecting these string you can spot instance of mimicards being used in the environment. Then rule info stealer detection. So detecting generic info stealer malware, this rule info stealer detection, so this rule is designed to detect info stealer malware. So these are typically used to steal sensitive data like browser password, cookies, or credentials. So it look for common file pattern and strings that are often associated with information stealer. So this is metadata, this is string. So if any string has info or stealer or this pattern, so this is going to catch the wide range of generic info stealer by targeting these identifiable patterns. Then last we have Cobalt Strike beaconing. So Cobalt Strike is a popular post-exploitation framework used by attackers for command and control communication and lateral movement. So this rule looks for traffic patterns associated with Cobalt Strike beaconing. Cobalt Strike beaconing is typically going to check the ASCII Cobalt Strike or beaconing strike against the network, and detecting cobalt strike traffic early can help identify persistent threat before they escalate further into more significant attack. All right, so wrap it up. So that's it for today. We have just learned how to write and use YARA rules to detect malware and other malicious activities. So these rules are like your malware detective toolkit, helping you to find traces of malware files, command and control communication, and even hidden payloads in memory. So what is next? Write your own YARA rule and start detecting those sneaky threats. Test and refine your rules as you learn more about the malware landslide or landscape, and share your findings with the community. And don't forget to contribute to the ever growing YARA rule repository. Stay sharp and keep hunting those cyber threats. If you like the video, please subscribe and hit the like button. Thank you so much.